Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The DL designation for carbohydrates refers to the configuration of the highest numbered chiral center, the penultimate carbon, relative to glyceraldehyde, not to the direction of optical rotation. Reasoning. The DL system is a configurational descriptor based on the spatial arrangement of the OH group at the reference chiral center. If the OH is on the right in the Fisher projection, the sugar is D. If on the left, it is L. Optical rotation, dextrorotatory plus or levorotatory dash, is an experimentally measured physical property that depends on the specific molecule and is not determined by the DL designation alone. For example, D-glucose is dextrorotatory, plus, but D-fructose is levorotatory, dash, yet both are D-carbohydrates. This disproves options A and B. Option C states a D-carbohydrate is always the mirror image of the corresponding L-carbohydrate. While a D-sugar and its enantiomer are indeed mirror images of each other, it is not accurate to say a D-carbohydrate is the mirror of the L-carbohydrate as a defining property of what a D-carbohydrate is. The D-carbohydrate is defined by its own configuration, not by being a mirror. More critically, option C is misleading because it implies the D form is defined as the mirror of the L form rather than by its absolute configuration at the reference carbon. The standard and precise definition is solely about the configuration at the penultimate carbon in the Fisher projection, making none of options A, B, or C fully and correctly descriptive of what a D-carbohydrate is. Since A and B are clearly false, D-sugars can be either plus or, and C is at best a consequence but not a correct standalone definition. The best answer is D, none of these. Therefore, the correct answer is D. Therefore, the correct answer is option D.